So this is the example. 4x plus 3y is equal to 4. 6x plus 5y is equal to 8. So these are the simultaneous equations with variable x and y. As first step, we have to check whether these equations are in standard form or not. So yes, these are in standard form. So our first step is completed. Then we have to go for step number 2, d, dx and dy. So first we will find the value of d. So determinant d, we all know that the first row consists of coefficients of x and y from equation number 1. So this is equation 1 and this is equation 2. So the coefficient of y in equation number 1 is plus 3. So I will write this 4 and plus 3 in first row of determinant d. So this is 4 and this is plus 3. Similarly, I will write coefficient of x, that is 6, and coefficient of y, that is 5, which belongs to equation number 2 in second row. So this is coefficient of x and coefficient of y of second equation, which is written in second row. So in this way, we write the value of determinant d. Now, after solving this, the value of determinant d as 2. Now, we will write the determinant dx. To write this determinant dx, we will go to determinant d. In this determinant d, what we do? We replace the coefficients of x of equation 1 and 2 with constants, that is 4 and 8. So this 4 and 6, which belongs to first column of determinant d, will be replaced with constants 4 and 8. And this remaining column 3 and 5, which belongs to coefficients of y of both the equations, will be written as it is. So after writing this determinant dx, we will simplify this in this way and we will get the value of dx as minus 4. We will write determinant dy. This determinant dy is written using this our determinant d. To write determinant dy, we replace the coefficients of y from both the equations with the constants, that is 4 and 8. After replacing this column of coefficients of y with 4 and 8, we write the coefficients of x of determinant d as it is in determinant dy. So in this way we write the determinant dy. Then after writing this determinant, we solve it and obtain the value of dy, which comes out to be 8. Here you can see that the value of determinant d is not equal to 0. Therefore, the Cramer's rule is applicable. Therefore, the unique solution of these two equations exist, and it is find out using this formula. X is equal to dx upon d, which is equal to the value of dx is minus 4 and the value of d is 2. So after substituting this, 2 ones are 2 and 2 twos are 4. So what we get the value of x as minus 2. Similarly, we find the value of y. Y is given as dy upon d. Once we put the value of dy, which is 8, and the value of d, which is 2, Then what we will get? 2 ones are 2, 2 twos are 4. So this 4 will be the final answer of y. X is equal to minus 2 and y is equal to 4 is our required answer. So we will write it in this way. X is equal to minus 2 and y is equal to 4 are the required solution of this given simultaneous equations using Cramer's rule. I hope this has given you complete understanding of this Cramer's rule. Now we will use Cramer's rule for solving these two equations. So I will mark this as equation number 1 and equation number 2 as these are already written in the standard form. So our first step has been completed. In second step, we write the determinants d, dx and dy as this is simultaneous equations with two variables and solve them to find their respective values. So determinant d can be written as shown. See, this is 3 and minus 4. These are coefficients of x and y of equation number 1. Therefore, they are written in first row. Here you can see that this minus 4, it is written with its sign over here. So in this way, we have to pick up this entire number with its sign. Then we write the coefficient of x and y of second equation in second row. So after writing the coefficients of both the equations, we will solve this determinant and find the value of d in this way. Now this value of d comes out to be 25. Similarly, we will write determinant dx. Now we all know how to write determinant dx. To write this determinant dx, we replace the column of coefficients of indeterminate d with constants of both the equations. So the constant of first equation is 10. We write it over here in first row and first column. Similarly, we write the constant term of second equation in second row and first column. Then we write this column of coefficients of y as it is. Now once we obtain the determinant dx, we will find out the value of dx, which comes out to be 50. Then we write the determinant dy, which is formed by replacing the column of coefficients of y with constants. Here you can see that the coefficients of x is written as it is, and this coefficients of y is replaced with constant terms, that is 10 and 5 over here. You can see that. Now once we write this determinant dy, then after solving this, we get the value of dy to be minus 25. Now once we get the value of d, dx and dy, we find out the value of x and y. Also here you can see that the value of determinant d is not equal to 0. Therefore, the unique solution of these two simultaneous equations with two variables exist. Therefore, we will find it out. So x is equal to dx upon d. After substituting values of dx and d, we will get 50 upon 25. So 25 under 25, 25 is 50. So the value of x is 2, and the value of y can be found out as dy upon d. is equal to, so the value of dy is minus 25 and the value of d is 25. So this 25 will get cancelled, and what will be remaining is minus 1. So value of y is minus 1. Value of x is 2. Then our final answer will be x is equal to 2 and y is equal to minus 1. So in this way we use Cramer's rule to find out solution of simultaneous equations with two variables. Now here is the practice questions that you have to answer. This is based on the concept that you have learned just now. After solving these questions, you have to write its answer in the comment box. Those who will give me correct answers, their answers will be given hearts in the comment box.